Thanks for the nice introduction. My name is Ahmed M. I'm assistant professor at Queen Mary University of London. And today I'm going to talk to you about AI and edge technologies for fostering SDGs. So I'm going to highlight a recent paper that published in Nature Communications about AI's role in SDGs. And it looked into the impact of AI, the positive and the negative impact over all the 17 goals and all the 169 targets, and try to look into what AI can enable or can foster, and what it can inhibit or make negative impact. So it found that AI can be enabler for, as reported in this study, it can be enabler for 134 targets, and it can be inhibitor for 56 targets among all the 169. So mainly they find that AI is enabler via technological improvements, which allow us to overcome many limitations in these targets. And they try to categorize and classify these targets into general areas, such as their impact on society, economy, and environment. So first, on the society part, they found that AI can have a positive impact by supporting the provision of food, health system, water, and energy in smart cities and smart grids and electric vehicles and smart appliances. However, AI can have a negative impact because normally it's usually these systems are mainly accessible to the wealthy people. And this can create several or issues with inequalities, bias, and in some cases hate or biasing citizens. Basically, such as in some countries they use citizen score to control the behavior or to reward good and bad behavior, which is driven by AI systems, which can be in some cases problematic. So they looked into also its impact on economy, and they found that it has a positive, of course, impact, where AI-enabled technologies are usually associated with increased productivity and can help us with many, reducing or solving many sources of inequality and conflict. However, this requires some proper AI, systems that can ensure unbiased, systems. For example, AI is used for, job hiring or, going through CVs or people's application. And for this case, we need this to be unbiased. So the problem now, it still have a negative impact on economy, where in some cases, as AI, if it is trained on biased data, it will become biased as well. So that's going to be a problematic, leading to some inequalities, especially between inter and intra nations. And also it can lead to many political polarization that can impact actually eventually the economy. So that is the impact on economy. And there is also, of course, the impact on environment. So the positive side of AI is that it could analyze large-scale data sets. It's designed to, consume data and generate, predictions and insights, which can be useful for developing joint actions for, environment preservation. Like, for example, detecting oil spills, climate simulation, energy-efficient systems. All of this can be developed via AI solutions. The problem is with the impact of AI itself is that training AI or ML models, especially the large ones, consume high compute and energy, and by themselves they have significant, carbon footprint and emissions. So, and also the problem with access to AI information system or ecosystems that rely on AI may drive over exploitation of resources. So these are the issues with AI for the environment. Now I'm gonna go through some of the challenges and the potential solutions, and I'll present next after this what we are doing in our lab or my group to solve some of these issues. So one of the challenges for AI is the lack of real and timely datasets. Normally, most of the experiments run in research are run in controlled lab environments or based on unrealistic data sets or synthetic data or just a prototype. And this may not reflect on the real environment. So the solution to this, we can think of relying on distributed real user IoT data that exists on the edge and in the wild. So, and this makes the system more reliable and more realistic. The second issue is how to democratize the computation, because most of AI applications are monopolized by big tech companies who own all the computational power that can, process and train data on these systems. So we need to shift some of the these methods or algorithms to a decentralized method to be able to, democratize computation and not keep them with the big tech companies. Another issue is, as we said, the energy and carbon footprint of AI. As we said, training them is quite resource and energy consuming, resulting in very high emissions. So we need to find energy-aware AI methods that can better utilize the resources and reduce their energy consumptions. The last issue is AI safety and robustness, and this is a very big issue. So as we said, AI models can be naturally biased due to the heterogeneity in the data and the resources, or in some cases, there can be malicious actors in the system that try to bias the AI model if we are relying on global data or decentralized data. Also, we need to solve this, we need methods that are robust to this heterogeneity and adversaries as well. So in my lab or group, it's called the Scalable Adaptive Yet Distributed Systems Group, which is based in Queen Mary, University of London. We look into issues related to how to decentralize AI and make them efficient. So our finding is that now, most of the data actually now lives at the edge. We have our mobile devices, smart home systems, electrical vehicle, autonomous vehicles as well. And all these systems are constantly generating data. So most of the data now is generated on the edge rather than being on the servers in the cloud or at the big companies. So, and mainly we know that the data enables the products and the smart models that is used within these products. And by the recent advancement in hardware and also the privacy restrictions that have been introduced by GDPR recently, that make us to think about solutions that, moving computation from the cloud or the systems developed by big tech to move them to the edge. And this is enabled now by, devices becoming more capable, our own devices becoming more capable, and also the privacy restrictions have forced us to do this. Also, there are other benefits to do moving from the cloud to edge, which is, improve the latency and all the solutions can work offline. It's better for energy and battery lifetime, and also it gives us privacy advantages. So that's why, many distributed machine learning systems have emerged recently. And one of these systems is called federated learning. And actually, federated learning is quite popular now that it has been used in many scenarios and domains. It's being used in education systems, healthcare, banking, and economy, and transport. And the idea is that we have organizations or entities that each own the data, and they want to collaboratively train a global model for making, solving a certain task. Maybe it can be voice recognition or next word prediction or whatever it is. So the idea is that we want to collaborate using our own data without moving our data. So this is the use cases of federated learning, and also big tech companies are using this, and we're the leading users of federated learning, such as Google is using it for next word prediction on their Google keyboard. Apple uses it for Siri for the voice recognition task, and Microsoft, because it's an infrastructure company, they deployed FL platform that can be used as a service. So moving on, our research, goal is to develop also federated learning frameworks. And one of the goals we were trying to aim for is democratizing the computation. And since, as we know, we have various, devices with significant different, computational power from low-end to high-end devices, the problem is when they participate, some of them may not be able to finish their training and may not be able to contribute. So we have used some compression techniques to basically reduce the model size and basically allow them to participate in the training. And this work has been published in EuroMLSys. Another work that we looked into how to make the system more energy efficient by looking at the energy consumption on these mobile devices and how to basically select them in an energy aware manner so that we select the devices that have low energy impact. And this is also a work that have been published in Mobicom. Another work we have been doing is combating adversaries or the malicious clients in the system, because some of them, they may try to bias the model toward certain goals that is not the target task, and that can be problematic. So we investigated some techniques related to curriculum learning. It's an emerging technique in machine learning that relies on training the model based on easy samples first, then introducing the harder ones at later stages. We use some branch in this curriculum learning to basically detect who is malicious and who is not. And this is showed very good results so far. For most of the work I have, you can check my Google Scholar by scanning this barcode and looking at our recent paper. And this is mainly my focus in my group. And we have also now we have been looking into digital twins. It's a new technology that have been emerging recently, and we were looking into how to use this for the Sustainable Development Goals. And at Queen Mary, we have been establishing now a lab that is going to be released soon. It's a multidisciplinary research lab. It's called DT for SDG. And the lab aims to bring together a team to research innovative digital twin solutions for assuring sustainable development goals. And the lab consists of multidisciplinary experts in digital technology, social science, and other domains. And also we have subject matter experts that are guiding or acting as a steering committee in the lab. So the idea of digital twin approach is that we have all these technologies that are in use. We have cloud intelligence, we have now edge intelligence, we have IoT and connected sensors and actuators. So the idea is to create a digital twin or a virtual replica of the real world system and try to look into how we can develop new solutions and experiment with them before deploying them in practice. So the digital twin is an exact replica that exists in the virtual world. And by experimenting in a digital twin, we can create innovative solutions that can be deployed in our smart cities of the future. And there is also, we rely on IoT sensing data that exists in the wild for the digitization of this digital twin. So that's the main idea of the lab, and the lab actually consists of a multidisciplinary approach. As we see, the lab consists of people from science engineering, medical and dentistry, and human science and social science as well. So the lab will look into Internet of Things, artificial intelligence, cloud computing, social science, energy, transport, and environment and climate. And we'll try to find a solution, integrate a solution for all of these problems within this lab. So the lab experts, as we can see here, consist of technology experts, and I'm a member of the lab focusing on cloud systems and cloud and edge systems as well. And it consists of many experts led by Dr. Mona Jaber at Queen Mary University of London. And we have also domain experts in energy and future mobility and transportation. We have also supporting renowned academics like an AI expert, digital health, and human geography as well. So I'll finish by some examples of the projects led by the members of the lab. We have these projects like service treatments for next generation quiet aerofoils and improving the robustness of urban electricity networks. Also another project aiming at decreasing jet installation noise. And there is another project using machine learning for water quality prediction. And another project is about occupancy enhanced smart cities. And the recent project by Dr. Mona, which is distributed acoustic centers for modeling active travel in the smart cities. So by this, I will finish my presentation, and thank you for having me.